Nobody is perfect. Einstein's faux pas discovered by Horst Eckardt of AIAS and president of UPTech. The great physicist Albert Einstein brought out in the years 1905 and 1915 his two important theories of relativity. This was initially received by experts with mixed feelings, to say the least. The breakthrough came when the results obtained through the use of his theory for calculating the deflection of light by the sun was confirmed by Eddington through observation in 1919. Today we know that these experiments were extremely dubious, but the concept was later confirmed to be reliable, as shown by NASA's Cassini spacecraft. The calculation of Einstein is very opaque, and it is not really clear how he came to the experimentally correct result. Einstein managed the feat of calculating the deflection of a small mass, a photon or light, by a large mass, the sun, although the mass of the photon in the calculation was not involved. Unfortunately, his calculation has turned out to be erroneous. As part of the refurbishment of Einstein's ideas, the AIAS Institute, Alpha Institute for Advanced Study, has dealt with this issue through investigations related to the space metric. As is known, the curved space in Einstein's General Relativity theory can be described by a metric. For a spacetime with spherical mass distribution, it takes a relatively simple form. The ECE theory, Einstein Cartan Evans theory, an extension of Einstein's theory, provides this form also. It follows that the results based on the investigation of the metric obtained by ECE theory are equally valid for the classical theory of relativity, which is used in the standard physics. One application of the space metric is the calculation of the deflection of light by massive stars. Einstein, shortly after completion of his general relativity theory, used it to calculate the deflection of light by the sun. During a solar eclipse in 1919, Eddington tried to measure this deflection experimentally. However, this deflection is in fact very small, only a fraction of a second of arc. Therefore, many legends have grown around this measurement, and it is probably true that the measurements were too vague and had no probative value. Meanwhile, the alleged deflection anticipated by Einstein's theory has been confirmed by the Cassini space probe, so that the experimental facts of deflection as such are no longer in doubt. All the greater was the astonishment when Myron Evans tried to understand the calculation procedure carried out by Einstein, a method which in fact was not documented properly at the time. In a book by Wald, this calculation is explained in general terms, but with indeterminate results which cannot be correct. So the solution of an equation of third degree is given by Wald, for which modern computer algebra programs provide a different value. But this is only one small detail. The fact that light is deflected by gravity leads to the assumption that photons are not massless but have a mass, although very small. Einstein accepted this, but then eliminated the mass from the calculation in order to simplify it. We should remember that there were no computers nor mathematical software packages available in the early 20th century, so the result is not consistent. In detail, Einstein approximated the light ray by the form of a circular orbit near the sun. This led his calculations to a fractional expression with a hidden zero in the denominator, which gives the whole fraction at a certain point an infinite value. On closer inspection, one sees that by adopting the circular path, the photon mass falls out of the calculation and the divergence to the integral calculation appears. So we cannot make use of this approximation. This is exactly what Evans avoids in his alternative calculation. This new mathematical procedure keeps the photon mass in it, and the mentioned divergence does not occur. Under some additional assumptions, which Einstein also made, the correct experimental value for the deflection angle is obtained, and the photon mass can be estimated using the Planck distribution. This is the first reliable estimate of photon mass from light deflection and also from time delay. But let us further consider Einstein's solution. As mentioned above, the formula leads to a divergent integral expression for the evaluation of the deflection angle. The expression for the integral is not contained in mathematical standard tables, so there is no analytical solution. Einstein, however this was achieved, obtains the experimentally correct value of a formula as delta phi equals 4mg over rc squared, where m is the solar mass, g is the gravitational constant of Newton, r is the solar radius, and c is the velocity of light. Fortunately, in this age of computer technology, integrals can be evaluated numerically to high precision. Evans and his staff have made this numerical effort and obtained a value of Einstein's integral, which is different from the analytical result claimed by Einstein. They also demonstrated that Einstein's own integral does not give Einstein's own claimed result. So the Einstein theory of light deflection is not valid. The new theory based on photon mass was developed using computer integration, not using incorrect analytical approximation. We have to remember that Einstein had no computer available, and his idea of a photon mass was quite primitive. However, it is surprising that his false procedure has remained hidden for almost a century. This is not good for science. It is apparently not deemed necessary by the whole international scientific establishment to review the theory, and one should not uncritically accept the findings of others. The shape of the light ray around a heavy mass has implications for cosmology. It is believed that extremely heavy stars, so-called black holes, capture light within a certain radius so that light moves in a circular orbit like a satellite around the black hole. According to the findings discussed at the AIAS Institute, orbits of light are not at all possible. There is a maximum deflection angle of about 3/4 of a full circle. When the light gets closer to the heavy mass, it is absorbed by it. The near field of a black hole, if there is such a thing at all, probably behaves differently from what has been presented to date. Evans wrote in his internet blog, "By now it is well known and accepted scientifically that there are at least two fatal errors in the Einsteinian theory of general relativity. The first is the neglect of spacetime torsion, and the second is a blunder in the theory of light deflection by gravitation, the same theory that catalyzed Einstein to fame in the early 20s. The ECE theory has set out to correct and develop general relativity. Other criticisms of the Einsteinian era are collected in the forthcoming volume, Criticisms of the Einstein Field Equation, Abramis Impress, by M. W. Evans, S. Crothers, H. Eckardt, and K. Pendergast. I have dealt with the consequences of this disaster for standard physics in an AIS.US essay, which has been published in Microbit. I have also recorded a talk on AIS.US using this essay, and can see that both essay and talk are being read to or listened to. The UFT 150 paper was the most read paper of AIS.US in June 2010. In a time of fiscal austerity, the waste of taxpayers' money on obsolete physics should be curtailed all across the world and switched to new research on energy and counter-gravitation. ECE has put both on a scientific footing. Finally, a word to the critical readers who reject Einstein completely and who assume rather the cause of the gravitational force to be that of ether flow instead of a curved space. From a mathematical point of view, both concepts are equivalent. The trajectories of a simple mass in the ether or in curved space are identical and are described by the same mathematics. In order to describe fluctuations of the ether, however, Einsteinian theory by itself is no longer sufficient, so it becomes necessary to move on to the ECE theory. Therein, ether fluctuations correspond to a variation of background potential. Space is not empty, as in Einstein theory, but filled with a potential of high energy density, which is known experimentally from quantum mechanics. All this can be described with relatively simple mathematics. Nobody is perfect. Einstein's faux pas discovered by Horst Eckardt of AIAS and president of UPTEC.